All right, let's start with our exercise 7. Okay, so this is our problem statement, and this is a chessboard. Okay, so as you can see, there is a black, then white, and then black and white. Well, a normal chessboard should be like 8 by 8 matrix. Okay, we can represent this black color as 0, this white color as 1, then again 0, then again 1. So this way we can actually create a checkerboard matrix like this. Okay, so our checkerboard matrix should be of size n. So n can be 5, 6, 7, 8, whatever. So we have to create a matrix in that way. Okay. So how we can actually create this matrix? That is the question. Now, so far we have actually learned like 25, almost 25 built-in functions, and I believe that we have created a list like I actually suggested, a list so that you can actually memorize those things. Okay, so those are actually the very basic uh, built-in functions that you will be using again and again. So I'm just providing you those things. Now let's add some two more there. Okay, so let's first create an array something like this. Let's say 0 comma 1. Okay, so I have an array like 0 comma 1. Now let's take a look at a function that is called repmat. Okay, I believe I have actually showed you this already. So it will take this matrix like A. Okay, so if I take this matrix A, then I have to provide the size. For example, if I write 2 comma 4, that means this will be repeated. This matrix will be repeated. There will be 2 rows and 4 columns. Okay, if you see, so this 0 1 was our original matrix. It is repeated into 2 rows. So now I have 2 rows and 4 columns. Now again, this whole matrix 0 1 is actually repeated 4 times. 0 1 is repeated 4 times. Okay, so it is creating 4 copy and in 2 rows. Okay, if I write something like uh, say say for example 6 comma 4, then I have total 6 rows. Okay, so I have 6 rows and 4 copy. Okay, so 4 copy means there are total 8 columns. Okay, because there are 2 columns here. Now practice a little bit by yourself and see how it actually works out. So let's create something a bit more. So I had initially 0 1. Okay, let's look at something like 0 1 8. I create something like this. Now if I write something like comma 3 comma say 5, can you guess what is the number of rows and columns? You should be able to guess. So since this is a row vector, I will have 3 rows and 3 columns. Since I already have 3 columns, multiple by 5, so there will be 15 columns. So it is a matrix like 3 by 15. You can see 3 by 15 double matrix. Okay, so now let's create something different. So this was our 0 comma 1, and we can use a semicolon. Semicolon means I'm going to the next line. Okay, now then I'm going to write something like 1 comma 0. So I have a matrix like this: 0 1, then 1 0. If you look it here, this is like one of the fundamental block of this matrix. Like, so this is one block. Okay, think of it like this way. So I am going to write a program based on that. Okay, so I have a matrix like this. So if I write something like repmat a comma, if I write some 1 comma 1, it will be repeated 1 comma 1. That means it is the same thing. So if I write like 2 comma 1, that means there will be 2 rows. 2 2, since now I have already 2 rows, so multiple by 2, that means I will have 4 rows, 2 columns. 4 rows, 2 columns. So the matrix, whole matrix is actually repeated. So if I actually write here, okay, let's see, our original matrix was like 0 comma 1. Okay, then we had something like 1 comma 0. Okay, so when I am writing this rep mat, this whole thing is like considered as one matrix. Okay, so if I write something like 2 comma 3, okay, it will create a replica of this thing. So replica of this thing, so I have 2, and then the replica of this whole thing 3 times. Okay, replica of the whole thing 3 times. So this is what actually what it is actually doing. It is repeating the matrix. Okay, so I hope it is clear. I believe it should be clear now. So what I want to do, so this is our matrix, right? So for example, for this one it should be like 8 by 8 matrix. So to create this one, this is our A, original A. To make this a 8 by 8 matrix, what do we have to do? I have to write a repmat function, and I have to do like something like 4 comma 4. Okay, so if I do that, so what I get, so I get this our this is our actually chessboard looks like 1 2 3 4 5 6 7 8. This is 8 by 8 matrix. So this is our output. Okay, for if our n was 8. Okay, here you can see I am been asked to create a, that is what we call a checkerboard matrix. So I have to create a function. The n should be the input. Okay, n is the size of the matrix. Okay, now so n should be the size of the matrix. Like for this one it is 8. So if it is 6, so I have to do something like 3 comma 3, right? 3 comma 3. Okay, but what if we want something like so this is a round. Okay, and this matrix is like of size 6, this was like size 8. What if I want size 7? What to do about them? What to do about that? Okay, so let's go there first. Let's do something like a function. So our function, okay, so this is our output matrix. Max should be equals to, okay, so this is actually checkerboard, name of the function checkerboard. So it will checkerboard matrix. Okay, let's name it a checkerboard matrix. Will take this n as an integer as an input, and let's save it. So it has been saved. Okay, so first what we are going to do is that we are going to create this block. Okay, so let's create this block. A is equals to our, okay, I just created it here, so I'm just copy. So this is our block. Okay, and we are going to repeat it. Okay, how many times we are going to repeat? For 8 we actually repeated it 4 times. For 6 we have repeated it 3 times. For 7, so what we are going to do, we are going to repeat it 4 times. Okay, and why is that? For example, one thing we can do, so for if I want like 7 by 7 matrix, so we can do something like this. Let's make it, give it a name, x is equals to something like that. Then we can just delete this row, delete this last column, and delete this last row. Then I'll get a 7 by 7 matrix, right? So it can be do by that, or you can also create a matrix like this 6 by 6 matrix. Okay, then you can just add a row and add a column. That will also create a 7 by 7 matrix. So you have to do it by yourself, okay, externally, because since I am creating this even block, so it can only be multiple of even number. It cannot create an odd number of blocks through this. Okay, we cannot create a half like that. So what we are going to do is that I am going to create this mat is equals to rep mat. Okay, rep mat, going to write this a, then I'm going to divide it by, so n by 2 comma, okay, n by 2, sorry, n by 2. But one thing is that, so if I write n 8 divided by 2, I get 4. If I write 7 divided by 2, I get 3.5. But I want something that is called 4. So how can we do that? Okay, so I have to, you can say I have to round it to the next integer, right? If I have something like 7, like this is a odd number. If I have something like 7, okay, I want to round it to the next integer. So how we can do that? There are some functions. Let me introduce you to those functions. First, let's write something like sail 7 by 2. Let's see what it actually gives. Okay, so sail, when I'm writing this, it is actually, it should be 3.5. It is rounding it to the next integer. So this is actually 4. Now let's see, try to look at another function, floor, then 7 by 2. So if I do something, it is rounding it to the previous integer 3. It is 3.5, but it is rounding it to previous integer. So we have actually learned quite a few new functions. So let's run it. For first we learned repmat, then we saw sail, then we saw floor. Okay, so sail will actually round our integer value to the next integer. So for example, if it is like 3.7, sail will make it 4. Okay, and floor will make it 3. Okay, previous integer. Okay, I hope it is clear. So I'm going to write here something that is called sail of atom. Okay, in that way, if I do something, so when I have like 8 by 2, okay, if I do it for 8 by 2, it is going to remain the same because it is already an integer, so it is not going to go to the next integer. Since it is an integer, the sail, placing sail or nothing, if we place sail, if we don't place sail, both are the same thing. Okay, so writing this, I don't have to write a conditional statement for even and for odd separating those things. I can just write this and I can just write our program in a single line. Okay, that makes it more convenient. Okay, so let's write this cell function again. Okay, so this is our rep mat, and so this should be our output. Okay, let's see if we are actually doing the way we want it to do. So this is our mat. So let's take a look at here. Checker, sorry, checker one matrix. Let's call the function here. Let's make it. I want to 8 by 8 matrix. So I get this 8 by 8. So if I write something bigger, so 14, so I get this 14 by 14 matrix. Okay, so say if I want something like 4, I get this. If I want something like 5, I get the 6 by 6 matrix because I have not coped it yet. Okay, so what we are going to do is that now, okay, so we have to write a conditional statement now, okay, later on, because so if what we are going to do, if you remember, there is a function called modulus. So modulus of n comma 2, not a division. Okay, remember here we are actually doing the division, there we are using this comma because this is a built-in function that takes two inputs. So if n comma 2, okay, is not equals to 0, if it is equals to 0, that means it is a even number. So I want to check if it is a odd number. Okay, so that is called not equals to, and the not equals to sign is something like this. Okay, not equals to 0. Okay, sorry, this is not this. Okay, now the previous one was for Python, so it's okay. Sometimes I actually sometimes you will see when you learn 3 or 4 programming languages, so these syntaxes might actually get jumbled up sometimes. It's okay, it's no problem. So for modulus of n comma 2, because it automatically shows an error. Okay, so that's actually the most interesting thing about programming writing in this IDE. Okay, that actually makes it more convenient because it automatically shows what kind of error you are actually making. Okay, so if our modulus of n comma 2 is not equals to 0, then what we are going to do, we're going to take this mat. So I want to delete the first row. Okay, the first row. So this first row and first column, or last row or last column, both are the same thing. So I want to delete, say first, I want to delete this first column. So how can we do that? Okay, so if you remember from your last week's lecture, so I am going to take all the rows and first column and make this empty. Okay, all the rows of this first column, and empty means this is vanished. Okay, then I'm going to do, so it has been vanished. Okay, then what I'm going to do again, mat of, now I'm going to take the first row, and all the columns, so all the columns. Okay, then make it vanish. So let's make it like this. So and then indeed I don't have to write another explicit else if or else for another one, because when it is equals to 0, when it is even, I am not changing my matrix, so it is remaining the same. So I hope it is clear. So let's run it. For 4 it is providing the right output. For 5, now as you can see, this is a 1 2 3 4 5 1 2 3 4 5 5 by 5 matrix. So our output is actually correct. So this is our checkerboard matrix. Okay, now I'm actually showing you these examples and solving these examples for you, okay, so that you can actually have a good hand on writing a program by your own. Okay, so please write those programs in your hand in your MATLAB. Okay, otherwise if you just watch these videos, that will be of no good. You will forget within a week. You will forget everything. Okay, so this is our checkerboard matrix. Okay, and this is something that is called rep mat. I have already introduced repeat element. Okay, rep lm, that is actually stands for repeat elements, and this is also something simple. Okay, let's take a look at here. 0, 1. You can also use this documentation, okay, to actually see how it actually works. So what it does is, so rep elements, what you'll do, I'm going to repeat those elements, say for example 1, 4 times. See what actually happens. So as you can see, repeat element. Okay, so when we are writing rep mat, repeat matrix, it was taking this whole thing as a matrix and repeating those things. And repeat elements take these individual elements at a time and repeat this way. So I said 1, 4. So one row, but 4 times. So first it will repeat the first element 4 times, then the second element 4 times. So if I write something like 2, 4, as you can see, it is repeating these things 2 times. 2 rows and 4 columns, and 4 for 8 columns because there are 2 elements. Let's increase this 0 comma 1 comma 9 comma 5. Then write this 2 comma 4. As you can see, there are total 16 elements. So practice a little bit by yourself and it will be clear. Now, before I finish, again, I want to introduce you to something a little bit more interesting. Okay, uh, so this is something what we call image process. Image. Okay, so introduction to image is something I will actually provide in a later lecture in full details. But since we have created um, this checkerboard matrix, let's see if we actually do something with it. Okay, so let's build a matrix something like this. For example, say zeros of 100, okay, comma, say 30, okay, comma, ones of 100, comma, 50. Okay, I'm suppressing the output, so you know what I am doing. I'm creating a zero matrix of 100 by 30 size, okay, 100 rows and 30 columns, and creating a ones matrix of 100 rows and 50 columns. Okay, I'm suppressing this because it will take a whole bunch of space. So this is our X. Okay, this is total 100 by 80 columns. Okay, now let's see if I do something like im show. So im show means image show. Okay, let's see if we can get something from it. So wait a little bit. As you can see here, what you see here, so there is something black and there is something white. So where does that actually come from? So if you look at here, what we have created here, first we have created something, rows of zeros. Okay, then we have created in something like ones. Okay, uh, let me show you something, okay, a little bit more, it will be more convenient. So let's reduce these things. Okay, and so if we reduce these things, it will be less easy. So let's so as you can see, there is a huge array. So I am creating an array of first, there are some columns. I have total 30 columns of zeros, then I have total 50 columns of ones, right? So when I'm actually creating this something like this 0 and 1, so I have like 0 0, and I have like total 30 columns of zeros, then I have all of one, total 50 columns of ones. Okay, so the image that you actually see here, the image that is actually represented, okay, that actually this 0 is actually stands for black. Okay, and this 1 is actually stands for white. Okay, so when I was creating this 30 rows, sorry, 30 columns, and this 50 columns of white, when we are viewing the image, as you can see, the black portion is less because there are total 30 columns here and there are 50 columns here. That's why we're actually watching this black and white image. So this is what we call a binary image. Okay, let me write it here. So this is what we call binary image. Okay, binary image. Okay, this is actually the first step of image processing or learning how actually the image representation of image. Okay, this is what we call binary image. So binary image is represented by only zeros and one. Now, the reason that I actually created this 100 by this huge matrix is that each of this 100, each of this point is actually stands for 1 pixel. Okay, so let's take a look at something, our checkerboard matrix. It will not be very obvious. So if I actually try to visualize this matrix, okay, I am show our answer, and let's see, we can actually visualize something like this. Okay, we have this. Let's copy this one out and let's run it. Okay, as you can see, this is very small. Okay, and but still we can actually visualize this thing. Okay, I don't think I can zoom it out. So each of the point is actually stands for 1 pixel. Okay, so when I'm creating this 8 by 8 pixel, okay, so this is our matrix. So this is actually our chessboard, and it's actually looks very interesting how we can actually represent these things with just a simple line of code. Okay, this simple like creating this simple matrix, I can actually create an image like this. Okay, so if I increase the size a little bit, say instead of 18, 8, we can actually create something like say 26. Okay, and let's try to do some image show. Okay, now you have this big checkerboard matrix. Okay, use. Okay, and later on, probably in next week, I will actually try to keep a lecture, a small lecture, one lecture on this image representation. It is, I actually find this very interesting, this image representation. Okay, so I believe it is clear, and try to work with work a little bit by yourself, and it is really interesting. Okay, so let's finish this.